Hi, so for this question, we're trying to find the state of two transistors Q1, Q2 right here, and we're trying to find current for B and C, so IB, IC, and then we're trying to find voltage of B and C, and we're given the information that B is equal to 100. So in order to solve that question, I first created four basic equations that are very crucial, and the first equation is B1 KVL. So basically B1 KVL goes through here, and the arrow right here. So VB1 is plus minus B1 is the arrow right here. And from this equation we acquire that 12 volts is equal to 1.2 million ohm, which is right here, times IB, current flowing through right here, plus voltage of B1, which is voltage from here to here, plus or minus from the arrow, which is the creation of equation here. And for equation 2, it goes from here to here. Let's do the voltage difference from here to here. And we see that is 12 is equal to VE, voltage of EB2, which is here, EB2, the arrow, plus voltage of CE1, which is CE1 is right here, plus or minus, and then through here. And the third equation that we see for KVL is C2, and we see that from here it's 12 volts is equal to voltage of EC2, which is voltage difference between here and here, plus 700 times IC2, which is 700 ohm here times the current flowing here. And the last equation, it's not really a KVL, but you can see from the drawing that current through IC1 is same as IB2. So to begin with this problem, we assume that Q1 is on, and which makes voltage of through BE1 right here 0.7 volts and current of IB greater than 0. And to test this, we put in our KVL equation 12 volts equals to 1.2 million ohm times BI current of B1 plus 0.7 that we assume from transistor Q1 being on, and we acquire current IB1 equal to 9.4 times 10 to the negative 6 amps. And since current of IB1 is greater than 0, we verify that Q1 on is correct. And from this following information, we acquire that IB2 is equal to IC2, which is greater than 0, and we also acquire the information that Q2 on is also correct as well. And from this we acquire that voltage through EB2 is 0.7. And then now we plug that information, or now we try to solve our CE1 KVL information, which is voltage through CE1 is equal to 12 volts equal to 0.7 volts plus voltage of CE1. We can do this because we now verified that voltage of EB2 is 0.7, and we see that voltage of CE1 is 11.3, and since voltage of CE1 is greater than 0.7 volts, we now not only verify that Q1 transistor is on, but we also verify that Q1 transistor is in active mode. So now we have to find the remaining information on Q2, and for that we find out that current of through IC1 is equal to 100 times current through IB1, and we find out that we acquire 0.94 milliamps. And using KCL, we find out that since IB2 is equal to IC1, and they're all equal to 0.94, milliamps. And for Q2, we start by assuming that Q2 is active, and by that we see that IC2 is equal to 100 because B is equal to 100 is given, and is equal to 100 times IB2, which is 94 milliamps. And from the active condition, we see that the voltage of C2 has to be greater than 0.7 volts. And using the KVL equation, we find out that the voltage of C2 is not greater than 0.7 volts. So the idea that Q2 is active is false. And now we test if Q2 is in saturation. And from here we see that voltage of EC2 in saturation has to be 0.2, and IC2 over IB2 has to be less than 100. And using the KVL equation, once again, we find out that IC2 is equal to 16.9 milliamps with the given assumption, and the ratio of IC2 over IB2 is less than 100, which satisfies our idea that Q2 is in saturation mode. Now, solving by using all these three KVL equations and the one KCL equation, we are able to find out all these values right here, which we already verified as I explained. And yeah, so Q1 is active, Q2 is in saturation mode. They're both on, and rest of the voltage and current are shown right here.